Tetherball is a game that involves a ball attached to the top of a pole by a rope. All right. Two players hit the ball back and forth. Suppose a player hits the ball so that it travels with speed v in the horizontal circle. Okay, it's traveling uh, at a speed. It's traveling in the horizontal circle with speed v. So label this v. And the radius of the horizontal circle is r. The angle the rope makes with the vertical is theta. So the angle that it makes with the vertical is theta. So you can see that this is theta. Okay, because this is with the vertical. And then okay, the rope makes with vertical is theta as model below. The ball has mass, so which means its weight acts downwards from here, from the center of mass, m times g, the gravitational field strength, and the magnitude of the tension force on the ball. Okay, so when we draw tension, we always draw away from the object of observation. So since this is the ball for us, so we draw tension like this and we label it force of tension. And now they're asking us to derive an expression for V, and assuming the rope's mass is negligible. All right, so in circular motion, we know that the centripetal acceleration is equals to v squared by r, and F is equals to ma, Newton's second law. And if you plug in a here, we get the centripetal force equals mv squared divided by r. So we can work from here to make v the subject, and we get fc times r over m root over v. Okay, so multiplying r, both sides cancel this, so we have r here, dividing both sides cancel this, so we have m here, and then dividing gives us this v. Now we know that fc, or the centripetal force, is in this case is provided by the tension, which is this component of the force, um, which is opposite to this theta. So this will be the sine component. So ft sine theta. If there was this component, the one adjacent, it would have been cos, but the centripetal force is given by this, provided by this. So we replace this with ft sine theta. So anything with cos cancel out. Now this does not have the root, so we'll cancel this one. And as you can see, ft is ft sine theta, so we have ft sine theta. We also have the r here, so we also have the r here divided by m. This one matches with our response perfectly, so we select D. All right, next question. We have block A and B of masses m, a, and b respectively are on a frictionless horizontal surface. The two blocks are in contact with each other. Right word force of magnitude F is applied to block A, and both blocks accelerate toward the right. Okay, so we have an acceleration in this direction, and the magnitude of the force that block A exerts on B. So this force A is exerting on B is force of A on B. Now, what is the correct relation between F and F of A on B? Now, because this force is responsible for moving the entire system of two objects, right? And then, so you could think like this way: F, the force that F provides, it gets used to, like used to some of like it gets to impacted in both MA and MB. So after it is after it is done with moving the block A, then the remaining portion of some, like remaining portion of this force would be used to move this one. So you can see like it's sort of distribution. some force is distributed for this one, and then it is distributed for this one. So definitely this one will be greater, right, than the force of A on B. So we select B then. All right.